Welcome back to my channel Bal Vigyan Bharti, and this is your mentor Avilash Sarkar. We are progressing on our trigonometric ratios. There we have discussed several the definition of the trigonometric ratios, the kind of trigonometric ratios, that is sine, cos, tan, cosec, cot, and sec. And then after we have established we have defined the relations between the different ratios, that is sine is nothing but 1 by cosec, cos is related to 1 by sec, and tan is equal to 1 by cot. Then after the ratios, how it is reacting when the angle changes from 0 to 90, 90 to 180, 180 to 270, and then 270 to 360, and multiple of that. We have established some generic formula regarding the angle and the ratios. Then after we have derived so many identities, corollary, and the formulas on trigonometric ratios. Then after we have discussed sine laws, cos laws. So this we have covered in 10 classes prior to this class. And as I have already told, once I complete the theory part, I will solve so many problems for you to make you understand better, as I did in the other subjects too. In this case also I'll do the same manner. So let me take you to the problem solving session, that is on trigonometric ratio. Trigonometric ratio. So this part will bring you to the problem solving session. The first of the problem, that is given sec theta minus 1 divided by sec theta plus 1. You have to prove it is equal to cosec theta minus cot theta. So this part is equal to this part that you have to prove. So the ratios are all can be brought or interlinked in somehow or other to each other. Means all 6 ratios you can correlate to each other by any means. Means if sine is equal to 1 by cosec, then cosec is related to cot is related to tan, and tan is so it is a cycle. So anything you can convert it into other in respect to the other ratios. So that if you keep it in mind, so anything like that when the ratios are given to prove in any relation, so that you can do by taking any part and can convert it into other parts. So here I will start with left hand side, where the expression is given in sec of the ratio sec, that means second, and that has to be converted into cosec and cot. So these are not in a direct relation, but somehow it can become. So what is the thing I will use, and this kind of ideas will come when you practice more and more in these same subjects. It's always is a thumb rule that if you be a master on any subject, you have to practice theory as well as the problems. So problems will give you more conceptual view on the subjects, so that will clear your thing more practically. So it is always better once you read or understood the theories, you do some sums on the same subject. That way it will, there may be some confusion when you read the theories, that you will clear when you will do the sums. So in that way this will do. Now in this case the idea is that I will bring something in the denominator so that I can transfer this denominator from 2 term to 1 term. So that is only possible if I can multiply with it with its conjugate. That means the 2 terms are of same kind, but the sign will change in between. So this same thing I have to multiply the both numerator and denominator so that the ratio value will not change. So if I do multiply the same thing numerator denominator, it won't change. So ultimately this will turns into a square and this will be a conjugate. So you know the result of this, it will remove the square root sign by removing the order, and this will turn into sec square theta minus 1. So what is that? You know sec square theta minus tan square theta is equal to 1. So sec square theta minus 1 is equal to what? Tan square theta. So if I under root, so it will come as only tan theta. So now if I divide into two parts, tan theta minus 1 by tan theta, isn't it? So if I write it that sec theta is equal to 1 by cos theta and tan theta is equal to sin by cos theta, okay, minus 1 by tan is equal to cot theta. Straightway that second part already came. Now cos theta can be cancelled out. 1 by sin theta, 1 by sin means cosec, so this will bring you to the right hand side. So this is nothing but equal to right hand side. So hence prove your thing. That is the task given to prove. So I have started to the left hand side, I have brought it into the right hand side, so hence it is proved. So the next sum number 2, tan theta plus sec theta minus 1 divided by tan theta minus sec theta plus 1. I have to prove it is equal to 1 plus sin theta by cos theta. So this is a very lengthy one. You have to bring it and to squeeze it something like that. So how do you do that? Let me start with the left hand side as I did in the last problem. Tan theta plus sec theta minus 1 divided by tan theta minus sec theta plus 1. So what would be the idea? So ideas may come in a different way, but in this case, what the idea that I will apply, it may not come in your mind directly, but if you practice more, it automatically will come. Because one, I can write it sec square theta minus tan square theta, and but the same thing I will not apply here, because I can see the further 3 steps where I want to reach. So that is very important. When you do something, when you calculate something, or want to prove something, or to establish something in mathematics, you always try to think 2 or 3 steps ahead. Then only you will be very successful, because once you visualize the thing that may arise after 2 or 3 steps, that will give you more confidence that the idea may vary. Means if you using some idea and that fails after 2-3 steps, immediately can come back to use another ideas. So that is my intention too, and that will come not by doing 1 or 2 sums. You have to do number of sums. Whatever way, whatever number is possible for you to do, just do it. Even if it is a repeated kind, even if it is a simple one, don't bother, do it. It will definitely give you much better idea to solve problems. So now it is sec theta minus tan theta, sec theta plus tan theta. Here the first part is sec theta plus tan theta. So I can take sec theta plus tan theta common from both the part. So the first part will remain with 1 because I am taking that whole thing common, and the second part sec theta minus tan theta and sec theta plus tan, that I have taken, so that will remain with sec theta minus tan theta only. Now in the bottom, as I didn't do anything, it will remain as it is as earlier. Now see what is the case, what are the things remaining, tan theta minus sec theta plus 1. tan theta minus sec theta plus 1. Here it is, on the top it is minus, sorry, I made a mistake. So it is a minus. So once you will take sin sec theta minus plus tan theta, the thing will change here automatically. So ultimately you see this part, this second part, and the denominator is matching. Sec tan theta plus 1, tan theta plus 1 minus sec theta. So this part, so this will cancel out. So the part which is remain here, which will remain here as the ultimate result is sec theta plus tan theta, that we have taken common from the two part on the numerator. Okay, so if it is so, will it not match the this thing? If I convert into sec theta means 1 by cos theta and tan theta means sin theta by cos theta. So if I take this LCM cos theta, it will give you the right hand side. So this proof your part, this is equal to this. So a bit tricky, but this kind of idea definitely will come if you practice more. Okay. Number 3, sec theta into 1 minus sin square theta. Sin square theta, that you have to prove 1. Okay, let me start with the left hand side. This is sec theta. Okay, now multiplied by 1 minus sin square theta. So this is bit easy. By seeing you can predict what we have to do. Now 1 minus sin square theta is equal to cos square theta. So sec theta, 1 cos square theta, the root will remove, so we will get cos theta. So sec theta means 1 by cos theta into cos theta, so that will give you 1, that is equal to right hand side. Okay, so problem number 4, given root tan theta, root 3 tan theta, sorry, is equal to 3 sin theta. Root 3 tan theta is equal to 3 sin theta. Prove sin square theta minus cos square theta is equal to 1 by 3. Okay, now using this you have to prove this. This is a different kind of thing. Now there is a thing that here sin and cos is involved, here only, and tan and sin. So if let me start with, as you can say, root 3 tan theta is equal to 3 sin theta. Okay, now, or you can do in any way, because root 3 and 3 you can cancel it out, so this will be root 3, so there is no use of this another root 3, so sin theta root 3, or tan theta means sin theta by cos theta is equal to root 3 sin theta. Okay, or what can you do, is equal to sin theta by cos theta, you can bring this at one side, sin theta is equal to 0. Okay, now take sin common, so this will be 1 by 1 minus root 1 by cos theta minus root 3 is equal to 0. Okay, or so that means if this has to be 0, either sin theta is equal to 0 or 1 by cos theta is equal to root 3. That means cos theta is equal to 1 by root 3. So sin theta, if it is 0, the sin theta is equal to 0, theta is equal to 0, sin 0 is equal to 0. But theta is equal to 0, that means this equation will not withstand, because tan 0 is equal to 0, sin 0 is equal to 0. So this doesn't have meaning. So this I cannot take it as a solution of theta. So the only thing cos theta could be 1 by root 3. So if it is 1 by root 3, what is sin theta? Is under root of 1 by cos square theta, so 1 by root 3. So root 3, so this will become root 2 by root 3 sine. So now if I put this value in here, so what I've got, cos theta is equal to 1 by root 3, sin theta is equal to root 2 by root 3. So I'm putting the value here, cos theta is equal to 1 by root 3 and sin theta I received as root 2 by root 3 by solving this. Okay, because what is sin square theta plus cos square theta is equal to 1, that I know. So cos theta is equal to 1 by root 3. So cos square theta is equal to 1 by 3. Sin theta is equal to 2 by 3. So sin theta is equal to root 2 by root 3. So now put this value. So if I put it in the left hand side of the equation, it will become root 2 by root 3 whole square minus 1 by root 3 whole square. So this will give you 2 by 3 minus 1 by 3, that is equal to 1 by 3. So hence it is right hand side proved. So you can say if it is true, so this is also true. Okay. Moving to number 5, and that will be the end of the last problem for this session, and we will move into the session together. Okay, evaluate, says evaluate cos square theta tan square theta, cos square theta tan square theta plus tan square theta sin square theta in terms of tan theta, in terms of tan theta. Now you can see one part already is taken, so it is very easy. If I take tan theta common out of these two, it will become cos square theta plus sin square theta. So it will not give you much pain. This is what? This is equal to 1. So this ultimately is equal to tan square theta. So you can represent this expression in terms of tan theta. That is very easy problem. So anyhow, I will move on to the problem number 6 in the next episode. Thank you for now. Good night.